to another Smash JAMB series, and today we're going to be looking at the topic chemical combination in JAMB chemistry. Now, let's take a look at these questions. Now, the first question says, find the empirical formula of a compound 69% carbon, 15.3% hydrogen, and 30.7% oxygen. Now, given that the molar mass of carbon is 12, hydrogen 1, oxygen 16, and then we're asked to find the empirical formula. Now, how do we do that? Now, it's very easy. I'm going to show you just how to do that. Now, what do you do? When you want to find the empirical formula of a compound, given its percentage by mass, all right, or given its mass. Now, actually, we're giving their percentage by mass. How do we do that? Now, we're going to write for carbon, we have what? 69 percent, all right? Then for hydrogen, we have what? 15.3%. And then for oxygen, we have what? And then for oxygen, we have what? 30.7% What are we going to do? We're going to divide each of these percentage by mass by their molar masses. All right. So the molar mass of carbon is 12. So we're going to divide carbon by 12. So it becomes divided by 12 over. We're going to divide hydrogen by the molar mass, which is what? 1. And then we're going to divide the oxygen by its molar mass, which is what? 16. Now, when we do that, we're going to have what? When we divide this, we're going to have 5.75. When we divide this, we're going to have what? 15.3. And then when we divide this, we're going to have what? 1.91875. Now, the next step, what are we going to do? We're going to divide each of them by the smallest, all right? We're going to divide each of them by the smallest. And if you look at it very well, you find out that the smallest here is 1.91875. So we divide each of them by the smallest. So we divide this by what? 1.91875. We divide this by 1.91875. And then we divide this also by 1.91875. All right? Now, what are we going to have? When we divide this, we're going to have what? 3 ratio. When we divide this, we're going to have 8 ratio. Of course, when we divide this, we're going to have what? 1. All right? So what's going to be the empirical formula? The empirical formula is simply going to be, now, we have 3 ratio 8 ratio 1. So the empirical formula is simply going to be what? C3H8O1. All right? Of course, the 1 is going to be invisible. All right, so this is our empirical formula. All right, this is our empirical formula, which is option what? Option A. So it makes option A correct. So this is how to find the empirical formula of a compound given its percentage by mass, or actually its mass. Now let's solve the next question. The next question says what? In electroplating steel with chromium, the cathode is, now when you electroplate steel with chromium, the cathode is going to be steel, while the anode is going to be chromium. All right? The cathode is going to be steel, while the anode is going to be what? Chromium. So that makes option what? Option B correct. All right? The cathode is going to be what? Steel, and the anode is going to be what? Chromium. All right? So that makes option B. They asked us for the cathode. The next question says, how many moles of the acid are present in 200 centimeter cube of 1.5 mole per dm cube of hydrogen chloride, HCl. Now, how do we do that? To get our answer very quickly, now we are given volume, and the volume is equal to what? 200 centimeter cube. All right. Now, we have to convert this volume from centimeter cube to decimeter cube. All right, so we have to convert this from centimeter cube to decimeter cube. That means from centimeter cube to dm cube. All right, now how do we do that? We are going to divide this by what? 1000. So we're going to divide this by 1000, and then when we divide by 1000, we're going to have what? This takes away this, 0 takes away this one takes away this. So 2 divided by 10, we have 0.2 dm cube. All right, so we've converted the volume from what? Centimeter cube to what? Decimeter cube. So they said how many moles of the acid are present? We have the volume, and then the concentration of HCl is given to us as 1.5 mole per dm cube. All right. Now, so the volume, we have it to be 0.2 dm cube, and then we have the concentration to be what? 1.5 mole per dm cube. All right. Now, a very easy formula that we can use to solve this is what? N is equal to CV. Now, what is N? N is the number of moles. All right. Number of what? Moles. Now, C is the concentration, and then V is the volume. All right. So the number of moles is simply going to be what? Concentration, which is what? 1.5 multiplied by the volume, which we've converted to dm cube, 0.2, and this is going to be 0.3 what? 0.3 moles. All right. So meaning that option C is what? Option C is our answer. All right. So the moles of the acid that are present in 200 centimeter cube of this concentration is what? 0.3 moles. All right, the next question says, what volume of CO2 will be produced at STP, that's at standard temperature and pressure, when 33.6 grams of sodium hydrogen trioxocarbonate 4 is subjected to thermal decomposition? All right, so what they are trying to tell us is that sodium hydrogen trioxocarbonate 4, which is NaHCO3, now when it is thermally dissociated, all right, or when it is thermally decomposed, it becomes what? It becomes Na2CO3 plus what? H2O plus what? CO2. All right. Now, what we're going to look at, what we're going to see is this equation balanced. Before we can start solving anything, is this equation balanced? Now we have two sodium here, and we have two atoms of sodium here, and we have just one. So meaning that we need to put what? 2 here to balance it. Now let's see if it's balanced. So we have 2 hydrogen here, and then we have 2 hydrogen here. Now we have 2 carbon here, and then we have 2 carbon here. Now we have 6 oxygen here, and then this is 3, this is 4, and this is 6. So now the equation is balanced. Now we can solve the question. Now the question says what? What volume of CO2 will be produced at standard temperature and pressure when 33.6 grams of what? Sodium hydrogen trioxocarbonate 4 is subjected to thermal decomposition. So what we are focusing on is between this guy and CO2. All right. Our focus is between what? This guy and what? CO2. So now what are we going to do? We need to find the mole of what? We need to find the mole of what? NaHCO3. Now we need to find the mole of what? Sodium hydrogen trioxocarbonate what? 4. Now, the mass given to us, all right? The mass given to us of sodium trioxocarbonate 4, hydrogen trioxocarbonate 4 is 33.6 grams. All right? 33.6 grams. Now, but what is the molar mass of NaHCO3? What's the molar mass? Now, let's get the molar mass. Now, this is going to be sodium, that is what? 23, plus hydrogen has a molar mass of 1, carbon 12, plus what? Oxygen, what? 16 times 3 atoms of it. So, all of this is going to give us 84 grams per mole. All right? 84 grams per mole. It's going to give us 84 grams per mole. So this is the molar mass of what? Sodium hydrogen trioxocarbonate what? 4. Now, we have to now find the mole. Now, how do we find mole? Mole is mass over molar mass. All right? Mole is what? Mass over what? Molar mass. All right? Mole is mass over what? Molar mass. So mole is going to be equal to, what is our mass? Our mass is 33.6 divided by, what is our mole? What is our molar mass? Our molar mass is what? 84. Now when you divide this, you are going to have what? 0.4 mole. All right. Now we know the moles, the number of moles of what? Sodium hydrogen trioxocarbonate 4. Now we're going to find the what? We're going to find the volume of CO2 that will be produced at STP. All right. We're going to find the volume of CO2 that will be produced at STP. Now, if you notice, 2 moles of sodium hydrogen trioxocarbonate 4 is going to produce 1 mole of CO2. All right. So 2 moles of what? sodium hydrogen triazocarbonate what 4 is going to produce what 1 mole of CO2. So 2 moles of NaHCO3 gives us what 1 mole of what CO2. And in 1 mole of CO2 at STP, we have what 22.4 dm cube of volume. All right, we have 22.4 dm cube of volume. So it means that 2 moles of this, all right, is going to produce what 1 times 22.4, that's 22.4 dm cube of CO2. All right, now we know that the mole of sodium hydrogen triazocarbonate 4 is what 0.4 moles. All right, 0.4 moles. So it means that 0.4 moles now will produce what x dm cube of CO2. So we're going to cross multiply. All right, so when you cross multiply, you have what 2x is equal to 22.4 times 0.4. So x is going to be equal to 22.4 times 0.4 divided by 2. That is going to be equal to what 4.48 dm cube. All right, that's going to be what 4.48 what dm cube. So it means that the volume of CO2 that will be produced at STP when 33.6 gram of sodium hydrogen triazocarbonate 4 is subjected to thermal dissociation will be what 4.48 what dm cube. Now let's solve the next question. Now the next question says, what is the IUPAC name of KMNO4? Now look at the options very well. This is, we have potassium permanganate, we have potassium tetraoxomanganate, we have potassium tetraoxomanganate 7, and then we have potassium tetraoxomanganate 4. Now if you watch very closely, you'll find out that this and this are disqualified from the options. Now why are they disqualified from the options? They do not what they do not signify the what the oxidation number of what manganese. All right, they do not signify the what oxidation number of manganese, and the oxidation number of manganese here is 7. All right, so the correct IUPAC name of KMNO4 is tetraoxo. Now tetra is 4, all right, tri is 3. Assuming it was 3, we would have said tri, but it's 4, so we are using what tetra. All right, so we have what potassium tetraoxo manganate 7. Why are we saying manganate 7? Because the oxidation number of manganese there is 7. So the correct option is what? Option C. Now the next question says, which of the following is a heavy chemical? Which of the following is a heavy chemical? Now what is a heavy chemical? A heavy chemical are chemicals that are produced in large quantities. Why we also have fine chemicals. Now fine chemicals are chemicals that are produced in what? Small quantities, but with a very high degree of purity. All right, so let's look at our option. Now drugs, dyes, and AgNO3 are actually what? Fine chemicals. The only heavy chemical here is H2SO4 because it is actually produced in what? In large quantities. So our answer is what? H2SO4. So H2SO4 is the what? Heavy chemical amongst all of these. Now let's solve the next question. Now the next question says, now we have the next question to be that we are giving a chemical reaction, and they said from the equation above, what mass of CaCO3, that's calcium triazocarbonate 6. Now we want to solve the next question, and they said from the equation above, what mass of CaCO3 will be required to produce 11.1 gram of CaCl2. Now how do we solve this? Very quickly. Now the molar mass of CaCO3 is 100 gram per mole, and the molar mass of CaCl2 is 111 gram per mole. All right, now let's check, is the equation balanced? Now we have Ca here, we have Ca here, 1. We have carbon here, 1, and then we have 1 carbon here. We have 3 oxygen here, and then we also have 3 oxygen here. We have 2 hydrogen here, and then we have 2 hydrogen here. We have 2 chlorine here, and we have 2 here. So the equation is actually balanced, and then we can move further. Now, if you watch very closely, you find out that 1 mole of what? CaCO3 produces what? 1 mole of CaCl2. All right. So meaning that we have to find the mole of what? CaCl2. So for us to find the mole of CaCl2, I said mole is mass over molar mass. Now the mass given to us, they said the mass of this, all right, of this is what? 11.1. all right. So it's going to be what? 11.1 over 111. All right, because they said from the question above, what mass of this, all right, will be required to produce 11.1 gram of CaCl2. So we have to get the mole of this here. So giving this mass 11.1 gram, so this is going to be equal to what? 0.1 what? Moles. All right, it's going to be what? 0.1 moles. So we can see clearly that 1 mole, all right, of CaCO3 will produce what? 1 mole of what? CaCl2. All right, so it means that 0.1 mole of CaCO3, all right, will also produce 0.1 mole of CaCl2. all right. So meaning that what? That the mass now is going to be what? The mass is the same mole of CaCO3 produces the same mole of CaCl2. All right, as we can see from here, from our analysis. All right, if 1 mole of this produces 1 mole of this, it also means that 0.1 mole of this will produce 0.1 mole of this. So the mass of this required to produce 11.1 gram of that is going to be what? Mass is what? Mole times molar mass. Mass is what? Mole times molar mass. All right, and the mole is what? 0.1 times what is the molar mass of CaCO3? 100. So that's going to be equal to what? 10 grams. All right, that's going to be what? 10 grams, which is option what? Option A. So that makes option A correct. All right. All right, so we want to solve the next question. It says, from the reaction above, what mole of CO2 will be produced from 56 gram of ethane? All right, now we're given the molar mass of carbon and hydrogen. Now let's check, is the chemical reaction balanced? That's the first thing you should check. Now we have 2 atoms of carbon here, we have 2 atoms of carbon here, we have 4 atoms of hydrogen here, we have 4 atoms of hydrogen here, we have 6 of oxygen. So this is 2 plus 4. So we have what? So the equation is what? Balanced. Now we can move further to solving the question. And I said, what mole of CO2 will be produced from 56 gram of ethane? Now we have to find the mole of what? Ethane, because now we have the mass, and mind you, the molar mass of ethane is what? 28 gram per mole, and then the molar mass of CO2 is what? 44 gram per mole. All right, so now let's find the mole of what? Ethane. All right, ethane, which is C2H4. Now mole is what? Mass over molar mass. Now what is the mass given to us? The mass given to us is what? 56 over what is the molar mass? The molar mass is what? 28. Of course, this is going to be what? 2 moles. All right, so from the equation we can see that what? 1 mole of C2H4 produces what? 2 moles of what? CO2. So now it means that 2 moles now, 2 moles of CH2 of C2H4 is going to produce what? Now you can see that 1 mole will produce 2 moles. So it means that 2 moles will produce 4 moles. We don't need to do any calculation here. All right, so meaning that the answer is what? 4. All right, the answer is 4. The answer is 4. So if 1 mole of ethane produces 2 mole of CO2, it means that 2 moles of C2H4 will produce 4 moles of what? CO2. Now that will be all for this video. Make sure you like this video, share this video, and hit the subscribe button. And after you hit the subscribe button, hit the notification button, so when I upload more videos like this, you get notified.